Alright, in this video we are going to work out some word problems involving trig functions like tangent, sine, and cosine. Problem number 1. The Ponce de Leon Lighthouse in St. Augustine, Florida is the second largest brick tower in the United States. It was built in 1887 and rises 175 feet above sea level. How far from the shore is a motorboat if the angle of depression from the top of the lighthouse is 13.25 degrees. Alright, let's draw a picture. Okay, so there's your lighthouse and your motorboat. Now, when they talk about angle of depression, that is always measured from the horizontal line. So you need sort of a horizontal line to start from, and then your angle of depression is going to be the angle down from the horizontal line. Okay, so the angle of depression is going to be this angle right here. Now the lighthouse is 170 feet above sea level, so that's 175 feet tall right here. And so if I wanted to put that on this triangle, then I could put that right here, 175 feet. Now, what are we supposed to find? How far from the shore is the motorboat? Okay, so the distance from the shore is this horizontal distance between the lighthouse and the boat. So we are trying to find this right here. Okay, we have enough information to find that. So from the perspective of the angle, 13.25 degrees, we have opposite and adjacent. We do not have the hypotenuse. The 90-degree angle is right here. So tangent function is what you should be thinking about. So you should be thinking, all right, the tangent of 13.25 degrees is equal to opposite over adjacent. So that's 175 over x. And then we have that shortcut that we learned, that you can reverse the position of the x and the quantity that's by itself when you have the variable in the denominator. So if I reverse these two, then that's immediately going to give me x equals 175 over tangent of 13.25 degrees. Okay, and we will need our TI-30 XS multi-view for this. So we'll just put this in a calculator. So we have 175 over tangent of 13.5. Oh, 13.25, not just 5. Let me try that one more time. Okay. So, let's see, how many decimals did they say? It doesn't look like they said. Let's go 2 decimal places then. 743.198, well, that's going to round to 20. Okay, that's the answer to number 1. Alright, the next several problems all refer to the same triangle. This is sort of a standard triangle where the right angle is C, and then the two acute angles are A and B. And then the way they name the sides is they use the lowercase letters, and lowercase a is always across from capital letter A. Lowercase b is across from capital letter B. And lowercase c is the hypotenuse, which is across from the 90-degree angle, capital letter C. So this is a standard triangle that shows up in textbooks and standardized tests very often. So this is going to be used for the next like 11 problems. Alright, Problem number 2. A is 37 degrees. B is 6. And find A. Alright, so this is what we're trying to find. Maybe I'll just highlight it. Alright, we're trying to find A. So, we have this angle, we have this side, and we're trying to find that side. Alrighty then, this is opposite over adjacent, so that means I'm going to use the tangent function. So that'll be tangent 37 is A over 6. Alright, opposite over adjacent. I will multiply both sides by 6. Okay, that's going to give me A. It'll be 6 tangent 37. Alright, how many decimals did they say? I forgot. Nearest tenth. That's 1 decimal place. So 4.5. Okay. I can't help but notice that these are not word problems. I might have to change the title of this whole video. Anyway, number 3. C is 16. B, angle B is 67 degrees. Find A. Okay, so we've got the 16 and the 67, and we're looking for A. So from the 67, we have adjacent and hypotenuse. So that is the cosine function. So we're thinking cosine 67 is adjacent over hypotenuse. To get A, we're just going to multiply both sides by 16. So those will cancel out. So 16 cosine 67. Alright, so that's 6.3. Got to round up. Number 4, angle B is 62 degrees. So 62. C is 24. Find B. Alright, from the 62 we have opposite and hypotenuse. So we're talking about the sine function. So sine of 62 is equal to B over 24, opposite over hypotenuse. To get B, we will just multiply both sides by 24. Alright, those will cancel out and just leave us with B. So 24 sine 62. That is 21.2. So that's number 4. Angle A is 29 degrees. Side A is 4.6. Find C. Okay, well, from the 29, we're dealing with opposite and hypotenuse. That is the sine function. So sine of 29, opposite over hypotenuse. So 4.6 over C. We can reverse the denominator with the thing that's by itself. So that's going to become C is equal to 4.6 over sine 29. So that's 9.5. Got to round up. Number 6. A is 17.3. Angle B is 77. Find side C. Well, from angle 77, we have adjacent and hypotenuse. So that is the cosine function. So cosine 77 is adjacent leg over the hypotenuse. So the denominator and the part that's by itself can be reversed. So that's going to give me C is equal to 17.3 over cosine 77. Double check 17.3 over cosine 77. So that's 76.9. That's number 6. Number 7. We have side B is 33.2. So this is 33.2. Angle B is 61 degrees. Find A. Well, from the 61, A is adjacent and B is opposite. So this sounds like a job for the tangent function. Tangent of 61, opposite over adjacent. So that's 33.2 over A. When the variable is in the denominator, you want to just go ahead and reverse these two quantities, which is allowed. So this will give me A is equal to 33.2 over tangent 61. So that's 18.4. So that's number 7. Number 8. Angle B is 49.217. I wonder why all the decimals, but anyway, angle B is 49.217 degrees. Side B is 10. Find A. Well, from this angle, we have opposite and adjacent that we're dealing with. So that's the tangent function. So we will do the tangent of 49.217. Opposite over adjacent. So 10 over A. When the variable is in the denominator, you should reverse these two quantities. So that's going to give me A is equal to 10 over tangent 49.217. Okay, so it's 10 over tangent 49.217. Double check. 10 over tangent 49.217. Yep. That is 8.6. Yeah. So that's number 8. Angle A is 16.917 degrees. I wonder why all the decimals, man. Seems silly. C is 13.7. Find side A. Well, from the perspective of this 16.917 degrees, we've got opposite and hypotenuse. That is the sine function. So sine of 16.917 degrees is equal to opposite over hypotenuse. So A over 13.7. Alright, we're not going to swap anything because we don't have the variable in the denominator. But we will multiply by 13.7 on both sides. That way the 13.7s cancel out. And that should give us the answer. So 13.7 times other things. Okay, sine 16.917. Okay, that is 3.98. So that 9 is going to have to round up. So this will be 4.0. Alright, maybe that's why they gave us all these decimals, just so it would round to a whole number. I don't know. Side A is 22.3. Angle B is 47.3. Find side C. Okay, from the perspective of the angle, we have adjacent and hypotenuse. So that's the cosine function. So cosine 47.3 is equal to the adjacent leg over the hypotenuse. Since the variable is in the denominator, let's use our shortcut and swap these. So that's going to give me C is equal to 22.3 over cosine 47.3. Yeah. $32.9. Alright, the escalator at St. Petersburg Metro in Russia has a vertical rise of 195.8 feet. The angle of elevation is 10.95 degrees. Find the length of the escalator. So I would interpret the problem this way. Vertical rise of 195.8 feet. Alright, angle of elevation is definitely going to be measured against the horizontal, so that's going to be this angle right here, 10.95 degrees. Now, it's slightly ambiguous when they say the length of the escalator, whether they mean this horizontal distance along the ground or the hypotenuse. I think they mean the hypotenuse, because this stair part of the escalator is the escalator. Alright, it's the moving stairs is the escalator. The rest of this is just empty space or whatever underneath the escalator. But the hypotenuse is the escalator, so there's nothing down here but wall. So that's the way I interpret it. So looking at it that way, we are dealing with opposite and hypotenuse from the perspective of the 10.95. So that sounds like the sine function. So we will do sine of 10.95 degrees is equal to opposite over hypotenuse. So that's going to be 195.8 over x. When the variable is in the denominator, it's helpful to reverse these. So that's going to give us x is equal to 195.8 over sine 10.95. So that should give you the answer. Alright, so that's 1030.8. Got to round up. Okay, feet. So that sounds like a long escalator. Alright, finally a word problem after all so many problems that weren't word problems. Alright, so there's just only one more word problem, and in fact this is the last problem, so let's knock this out. When a 757 passenger jet begins its descent of the Ronald Reagan International Airport in Washington, D.C., it is 3,900 feet from the ground. Its angle of descent is 6 degrees. So all that's shown here. What is the plane's ground distance? Okay, so the ground distance is here. Let's call it G for ground distance. It's not a very good G though. Okay, let's call it G for ground distance. Now, this 6 degrees is not inside the triangle, but these would be alternate interior angles. We have our parallel line. So if this is 6 degrees, then this will be 6 degrees. So focus your eyes on that. So we have opposite, and we're looking for adjacent from the perspective of the 6. So we're doing the tangent function, it sounds like. So we're talking about tangent 6 degrees is equal to opposite over adjacent. So that's 3,900 over the ground distance, opposite over adjacent. When the variable is in the denominator, it is convenient to swap these two quantities. So that's going to give us G is equal to 3,900 over tangent 6. So that is 37,106 feet. Alright, how far must the plane fly to reach the runway? Okay, I think now when they say how far is the plane going to fly, they're saying the actual path of the plane from the plane to the ground. That's the hypotenuse. So I'm going to call that, I'll just call that x. Okay, so forget about the ground distance, we already found that. So now we're dealing with these things. We have this number, of course, 6 degrees, and now the path of the plane itself. So from the 6, that is opposite and hypotenuse. So that is the sine function. So we'll be going sine of 6 degrees is equal to opposite over hypotenuse. Since the variable is in the denominator, it is convenient to swap these. So that will give us x is equal to 3,900 over sine 6. So that's 37,310.4. Alright guys, that's going to do it for this video. I hope it was helpful. See you on the next video.